Hi, so in this video we are going to discuss the differences between deductive arguments and inductive arguments. The chart that I have here in front of us is just a way of orienting what we've done and getting a sense of where we're going. We first talked about how arguments were a set of statements. And statements are the kinds of things that can be true or false. And arguments are a structured set of statements that reflect an inference. So they're a set of statements in which one statement is purported to follow from another set of statements. And then we distinguished between arguments and non-arguments by considering various kinds of non-arguments, many of which were also sets of statements, but they didn't reflect an inference, importantly didn't reflect an inference. And now what we're doing is we're moving on to talk about deductive and inductive arguments, which are the two general kinds of argumentation that you can have. So let's proceed to that. An argument is deductive or inductive depending on how the evidence that were offered, that is the premises, how they relate to what we're trying to prove, that is the conclusion. So it's worth bearing in mind that logic is the study not of the factual content of the arguments. That is, insofar as we're logicians and we're studying logic, we're not really worried about whether the evidence is in fact true or false, or whether we're justified in believing the evidence, the premises, as being true or false. Instead, we're worried about what kind of relationship instantiates between the evidence being offered and the conclusion that we're being told that follows from that evidence. That is, we're really interested in whether that conclusion does follow from the premises or the evidence. So again, logic is the study not of the factual content of the arguments, but of the evidential relations between the premises and conclusion of arguments. So insofar as we are just going to be logicians in this class, we're typically not going to be concerned about whether premises are true or false. We'll see that there's going to be a little bit of exception to that, but generally speaking, we're not worried about that. We're going to be happy to let scientists tell us whether premises are true or false. We're going to be happy to let historians tell us that. We'll be happy to allow other certain special fields outside of logic to tell us whether premises are true or false. We, though, are going to focus on whether the conclusion really does follow from the premises as the argument purports it does. And as I've said, there's two styles. There's the deductive style and the inductive style. So the relationship that can occur between the premises and the conclusion can be one of deductive, or at least purport to be the kind of style that the deductive arguments have. So a deductive argument incorporates the claim that it is impossible for the conclusion to be false, given that the premises are true. So the premises are our factual claim, and what the argument is in a deductive argument, what it's trying to suggest is if we end up accepting these premises, so we let our scientists or historians or whoever tell us that these premises are true. If they tell us that these premises are true, you're going to have to accept the you're going to have to accept the conclusion on pain of irrationality, because the conclusion is going to be guaranteed from that. So as I've put here in the side, deductive arguments employ necessary reasoning, which is an all or nothing. Either the conclusion really does follow from the argument, and you're guaranteed the conclusion if those premises turn out to be true, or it just doesn't follow at all. So it's binary, it's on or off, it's good or bad, it's beautiful, ugly, etc. In contrast, we have our inductive arguments. And an inductive argument incorporates the claim that it is improbable for the conclusion to be false given that the premises are true, also with an additional assumption that we haven't purposely left out any pertinent information that we're aware of. So, we didn't exclude any information that if we knew it might change our judgment about whether the conclusion is probable or improbable. So you'll notice that there's this sort of similarity in that we're still worried about truth preservation in deductive arguments and inductive arguments. The truth preservation that happens in deductive arguments is all or nothing. You got truth preserved or you didn't get truth preserved. But in inductive arguments, it's probabilistic, so it's in degrees. You either got over 50% chance of preserving the truth, which makes it more likely than not that the conclusion is true, or you got 50% or less, in which case it's not more than likely not, sorry for the double negatives, that the truth is preserved into the conclusion. So as I have over here, instead of employing this necessary reasoning, inductive arguments employ probabilistic reasoning. And so when we're thinking about just how much support that the conclusion has from the premises, or to what extent we can expect it to follow, it'll be in degrees instead of being binary on and off. There'll be different levels of strength of an argument, from very, very weak to very, very strong. So let's flesh out deductive arguments and inductive arguments in greater detail. Let's make it a little bit more concrete for ourselves. To make deductive arguments more concrete to ourselves, we're going to take a look at 5 examples. And you shouldn't be misled into thinking that this is going to exhaust the kinds of deductive arguments that are out there. It doesn't come anywhere close. In general, when trying to determine whether an argument is deductive or inductive, you should be thinking to yourself whether it implicit in that argument, whether it purports to maintain that the conclusion is guaranteed by the premises, so that all or nothing style of reasoning, or whether it purports that the conclusion is likely to be the case. So it gives us that probabilistic reasoning. But if you can identify, of these 5 kinds that we're going to look at, if you can identify that the argument belongs to one of them, then you'll know that you're dealing with a deductive argument, even if it's a bad deductive argument. So it purports that the conclusion is guaranteed by the premises, but it's not. It ends up being wrong about what it purports, in which case it's a bad deductive argument, but it's still deductive. It doesn't. One mistake that students unfortunately are prone to make is once they identify that an argument is bad and it's a deductive argument, you'll end up wanting to say that it's an inductive argument, but it's not. It's still a deductive argument, it's just a bad one. It doesn't even offer probabilistic support, it just fails to guarantee the conclusion. All right, so the first kind of deductive argument that we're going to look at is an argument based on mathematics. So the example that I have here is that Jimmy paid for an item paid with a $5 bill, and that item cost $2 even. So Bob, our cashier, gives back the correct change, so that's part of our premise. Therefore, we conclude that Jimmy got $3 back. And if those premises are true, that conclusion's got to be true. And it's got to be true based on what we mean by 5 and 2, so and the properties that surround those numbers, and also what we mean by subtraction. So when we put those numbers in that kind of relationship, and based on the certain properties of those numbers, we'll get a certain result. In this case, if we subtract 2 from 5, it's got to be the case that we end up with 3. So notice, so we have a deductive argument here. Notice that even if we changed it up a little bit and we said that Jimmy paid with a $5 bill, the item cost $2, Bob gave back the correct change, therefore Jimmy got back $2. We would still be dealing with a deductive argument because implicit in the argument is that the conclusion is guaranteed by the premises. It just turns out that this would be a bad argument because Jimmy would have to get back $3, not $2. So we just made an error. It'd still be a deductive argument. We just made an error in our reasoning. It's not a truth-preserving deductive argument. So the second one that we're going to look at is argument from definition. So basically the style of this argumentation is you say, here's this definition, here's what something means. So-and-so is this kind of thing, right? The word aptly describes this person. Therefore, and then you just say that description aptly applies to this person or thing as well. So in the example that I have here, Kelly is indigent. Now I left out the definition of indigent, but well, actually we can look it up. Indigent, poor, needy, a needy person. Okay. So I say Kelly is indigent, therefore she is impoverished, which is to say that she's poor. So if I know what indigent means, since my premise is that Kelly is indigent, it's got to be the case that she's poor. It's got to be the case that she's impoverished, that she's needy. All right, let's look at the next 3 kinds of deductive arguments we'll look at. So we're going to look at 3 kinds of syllogisms here. And the reason why these arguments are deductive is because of the structure that they're supposed to be employing. Sometimes the conclusion can be guaranteed merely by what we call the form of the argument, where I think for students to better understand, we mean the structure that the argument takes. To get some clarity on that, we can look at this categorical syllogism first. So it says, all humans are mortal. So all humans are the kinds of things that can die. Socrates is a human. So the famous philosopher really was a human, but let's go with is a human. Therefore, Socrates is mortal. The reason why this is a categorical syllogism is we're being told that certain categories of human, the categories of mortal things, the category that contains just one entity, namely Socrates, and again, the category of humans, we're being told that these relate in such a way that it's going to guarantee that Socrates belongs in the category of being mortal. So we can take a look at this. If all humans are mortal, then we have one category of mortal things, and we're told that everything that's a human falls completely within the things that are mortals. Now, of course, there can be other things that are not humans that fit in this category too. You know, your cats, unfortunately, right? Your cat and dog or whatever is going to die at some point. But what's important is that the things that are humans are all going to fit in these things that are mortal. And then we're told that Socrates is a human. So Socrates is in here. Well, notice that if Socrates is in fact a human, that is, fits in this category, then it's because all humans fit into the category of mortal things, it's got to be that Socrates is a mortal thing. And that's why this is a deductive argument. And even if you give it a bad categorical syllogism, because there's, as we'll see later on in this course, there's all sorts of different kinds of categorical syllogisms. So even if you give a bad categorical syllogism, it's still going to be a deductive argument, because implicit in the argument, it's purporting that those categories relate in such a way that it guarantees the conclusion. It just turns out that they're wrong. It just ends up being a bad argument. Okay, so that's categorical syllogisms. And we can look at hypothetical syllogisms. And hypothetical syllogisms are syllogisms that take this if-then form. So if, in this case, if Sam is taller than Jessica, then Sam is taller than Jennifer. So we could represent that as saying, if Sam is taller than Jessica, then Sam is taller than Jennifer. Our second statement says, if Sam is taller than Jennifer, then Sam is taller than Jim. So let B be the sentence, Sam is taller than Jennifer. Let C be, Sam is taller than Jim. Therefore, if Sam is taller than Jessica, which we already said was going to be A, then Sam is taller than Jen. So we're being told that if it's true that having A obtain will guarantee that B obtains, and it's true that at the same time, it's also true that having B obtains guarantees that C obtains, then because A will guarantee the B and the B is going to guarantee the C, it's got to be the case that if we get A, we're going to get to C. C is going to be guaranteed. So again, the reason why this is a deductive argument is implicit in the argument. We're being told that these states of affairs have this logical relationship such that the conclusion would be guaranteed if the premises are true. And that's why our hypothetical syllogisms are going to be deductive arguments. And even if we're given a bad hypothetical syllogism, which we can be given, the person that's giving that argument means or purports or is suggesting that the correct structure is taking place. They're just wrong about it. So it will still be counted as a deductive argument as opposed to an inductive argument. It'll just be a bad deductive argument. All right, last we have disjunctive syllogisms. Oh, so actually let me come up and talk just a little bit more about these hypothetical syllogisms. So the reason why we get the name hypothetical is when you have this if-then, it's kind of like saying, take this as a hypothesis, right? If this happens, then you're going to get this. So that's why it has the name hypothetical syllogism. Disjunctive syllogism, disjunctions are these either-or statements. So that's why this gets the name disjunctive syllogism. And here we're told either Bob went to the store or he went to the pub. So when we say that, for that sentence to be true, at least one of those things has to happen. It's got to be at least the case that Bob went to the store or he went to the pub. And then we're told that it's true that not one of those things happened. Namely, it's also true that Bob didn't go to the store. Well, if one of those two things has to be true, he went to the store or he went to the pub, but he didn't go to the store, then he better have gone to the pub. So again, we see that it's the structure or the form of this argument that is making the case that if those premises are true, the conclusion's got to be true, which is why deductive syllogisms will be deductive arguments. And again, we can be given bad disjunctive syllogisms, it turns out. And even though they're bad disjunctive syllogisms, they'll still count as deductive arguments, not inductive arguments, because implicit, or what the person who's offering that argument is purporting, is that it does have the right structure, that the conclusion is guaranteed by the premises. It just turns out that person is wrong, or that argument is bad, because it fails in what it's trying to suggest to us. All right, so now that gives us some sense of deductive arguments, and it also gives us 5 kinds that, at least when we see them, we'll know that we're dealing with a deductive argument. So I'll stress, before moving on to inductive arguments, I'll just stress one more time. Don't be misled into thinking that these are the only kinds of deductive arguments that are available to us. We're centrally always going to be concerned with whether the argument is trying to suggest that the conclusion has to follow absolutely from the premises and isn't merely given probabilistic reasoning. All right, let's look at inductive arguments. Some examples of inductive arguments. We're going to take a look at 6 different kinds of inductive arguments, and doing so is going to allow us to better identify whether an argument's inductive or deductive. But it's worthwhile stressing again that this isn't supposed to be an exhaustive list. What's most important, what's central in determining whether an argument is inductive as opposed to deductive, is to determine whether the argument is relying on probabilistic reasoning as opposed to that all or nothing reasoning that we saw with deductive arguments. The other thing to stress here is that many of these categories that we're looking at, they're not exclusive to the other categories, so to speak. It could be that an argument actually fits both characterizations, so they're not nice and neat categories. So it could be that there's arguments that are just as likely to be identified as being causal inferences as well as predictions, for instance. Okay, so let's look first at arguments from analogy and talk about the structure of arguments from analogy. So generally the idea in analogies is that you're making a comparison. You are saying that these things or events or whatever it might be have certain similarities. So you might say that thing or event X, there we go. Thing or event X has property A, B, and C, and thing Y has property A and B, and because X and Y are similar in these respects, they both have those properties in common, thing or event Y is also going to have C, whatever property that picks out. So here, the example that I have is say that Jacob bought a used Cavalier from Larry Automotive, and it runs great. So if I buy a used Cavalier from Larry Automotive, it'll run great too. So what we're saying is, hey, we've got these similarities, namely getting a car that's a Cavalier that's used from the same place, Larry Automotive, and because one car also has the property of running great, it'll follow that the car that I'm going to get is also going to have the property of running great. So again, the idea is that because we see these other similarities, we can expect one property that we know one object or event has, that this other object or event will also have that property. And when trying with some of the things to be, we're actually going to take a look at analogies in a much closer examination later on in this course. But one of the things to be thinking about when deciding whether we have a strong argument or a weak argument when it comes to analogies is whether the similarities that we're appealing to are germane to the property that we are wanting to conclude. And what kind of information might be relevant to it, right? So the argument that we have here is pretty weak, just because Jacob bought a used Cavalier from Larry Automotive. I mean, there's some reason to think that because you're getting it from Larry Automotive and you got a good car from there, you might get another good car because maybe their technicians are good, their their mechanics and whatnot. But you're not told whether this used Cavalier that Jacob got, whether it's just a year old, whereas the one that you're getting is 20 years old. If there's that kind of a difference, you're there's a great chance that even though Jacob's runs great, yours isn't going to run great. So just based on the information that we have here, even though it's giving us some evidence, right? Because inductive arguments, we get degrees of support. It probably doesn't get us over 50%. It probably misses that mark, and so it's going to be an overall weak argument and not the kind of argument that's really going to convince us of the conclusion. So let's turn our attention now to predictions and the structure of predictions. So the main point of a prediction is that you're making a claim about the future, right? So you're using some evidence of some sort to then make a claim about the future. And oftentimes when making predictions, we'll use past occurrences. So we see a particular pattern and we expect that pattern to maintain or likely to continue into the future. So here we have tomorrow's Friday. Nearly every time I see you on Friday, you're cheery. So you'll probably be cheery tomorrow. Right? And that's going to be a strong argument. Of course, it doesn't guarantee the fact that tomorrow's Friday and let's say 9 out of 10 times I see you on Fridays you're cheery. It doesn't follow 100%. We don't get that all or nothing type of reasoning here that you will probably be cheery tomorrow. All you get in the case that I've drawn up is that you have this 90% chance. So, it's a good conclusion to make. It's a pretty strong conclusion to make in this case, but it's not, it doesn't have that all or nothing character, so it's an inductive argument. All right, let's look at some other kinds of inductive arguments. So the next argument that we're going to take a look at is generalizations. And the structure of generalizations runs something like this. So you start getting a sample. So you start finding instances of a kind of thing or a kind of event, whatever might be the case. So here's one instance, and it has a particular property. So again, a kind of property, right? In this case, property P. And then you find another instance of that kind of thing, and you see that it also has property P. And right? You could just have potentially two cases, but you could have several cases also where you find instances that have this property. And as a result, you end up concluding that something to the effect of all A's have P. It's supposed to be an S, okay. So you have a sample population, and then you move to the fact that your sample population keeps exhibiting this property. The whole population, right? You generalize out to the whole population that they have P. Of course, if you see some counter examples where you have A, sub 4 or sub 5, or maybe it's, so let's say A sub 1 through A sub 59 all have P, but A sub 60 doesn't have P. Well, you might say something like most or the vast majority or such a percentage have P. You generalize out in terms of percentage as opposed to all, but you're still making that move from going from a smaller population of what's in question to a more general claim about that population as a whole. And the example that I have here, so you can imagine a situation in which you have little glass vials, and you go to this lake and you collect these samples of water, and you test them to see whether there's petroleum byproducts. So the sample of water we obtained from Clinton Lake shows high levels of petroleum byproducts. Therefore, all the water in Clinton Lake is contaminated with high levels of petroleum byproducts. So we have that sample, right? Because we have these samples of water. They have a particular property, in this case being contaminated with petroleum byproducts. So we generalize out to the claim that all of the water, every bit of the water that is in Clinton Lake, is going to be contaminated with petroleum byproducts. And the strength of this conclusion is going to depend on some certain factors. So the more samples that we have of water that's contaminated, the stronger our conclusion that all bits of water of Clinton Lake are contaminated becomes. And if we collect those samples in a random fashion, then that's also going to strengthen our conclusion. And so strengthen the likelihood that our conclusion is true. So you could imagine that we didn't collect the samples randomly. Suppose that all the places I collected water were at fueling stations for boats. If that's where I collected all my samples, then we might expect that my conclusion is actually improbable, that it's not likely to be true. Why? Well, we expect the water surrounding the area where we fill up our boats with gas to have higher levels of contamination of petroleum byproducts. Why? Because we would anticipate that people are sometimes going to spill gasoline into the lake there. So we have to be worried about our methodology
when engaging in generalizations. Let's turn our attention now to arguments from authority. So the idea of arguments to authority is you're treating somebody as if this person is an expert, and not only an expert, but an expert on the particular topic that's in question. So authority, we're talking about expert, and it's going to be a strong argument insofar as your person who's an authority is in fact an expert on the thing in question, whereas it goes awry or it goes wrong when we treat somebody as an authority on a topic when they're not in fact an expert on that topic. So an example of a good strong argument that's an argument from an authority, we have Dr. Magoo, a well-regarded psychologist, suggests that Sean has obsessive-compulsive disorder. Therefore, Sean has obsessive-compulsive disorder. Well, obsessive-compulsive disorder is the kind of thing that psychologists are aware of. We're even told that this is a well-regarded psychologist, so he's even, not only is he already an expert, but he's a particularly good expert. And he makes the judgment about Sean that Sean has obsessive-compulsive disorder. It's really likely then, it's more probable than not, given this expertise, that Sean does in fact have obsessive-compulsive disorder. We can contrast that in cases that arise where we have authorities making certain claims or judgments where they're not experts on it, and this unfortunately happens all the time. One of the cases was when Jenny McCarthy was making the claim. I think maybe she reversed or has a little more subtle view now, but she was making the claim that vaccines cause autism, but she's not a scientist. She's not the kind of person that you should trust when trying to decide whether vaccines do in fact cause autism or not. You also have Stephen Hawkins and Neil deGrasse Tyson will make claims about certain subject matters that they're not experts on either. They're both really, really smart people, and they're really smart people with respect to their own field. But if you hear them making a claim about things that don't have to do with their field, you should be suspicious about whether you should take it with more than a grain of salt about whether they're correct or not, or whether their position is probably true or probably false. Okay, so let's look at a couple of more inductive arguments. So the next kind of inductive argument that we're going to look at is arguments based on signs. And the way that these arguments work is one of its premises is going to appeal to a sign as evidence for the conclusion that's being offered. So this could be something like a traffic sign, or the example I have is this danger high voltage sign. It could be other kinds of signs too. Maybe you're tracking an animal, so you might use animal droppings or certain other things that display the behavior of that animal as a sign to formulate a conclusion. So in this example I have, you'll get electrocuted if you touch that wire. See the danger high voltage sign next to it. And being that danger high voltage signs aren't usually planted for no reason, just anywhere, when we see one next to exposed wires, that's really good evidence that the conclusion is probably true. Now, lots of students are inclined to mistake arguments based on signs as being deductive arguments, but they're not deductive. Notice that even if it's true that there's a danger high voltage sign next to a wire, that doesn't guarantee that it's a live wire. Why? Well, that can be right. We can have that sign there when we have a blackout, and you go and touch that wire when there's a blackout and you don't get electrocuted. You can it can be the case that you have someone who likes could be mischievous and decided that one way to be a jerk was to just start placing these danger high voltage signs around various wires around town. So even though it's normally, and it still would be reasonable to appeal to it, in this case, since it was planted there randomly, it's not likely to guarantee the conclusion to be true. All right, so that's arguments based on signs. The last inductive argument that I want to take a look at is causal inferences. Many students will want to say that this is causal inferences, but that reads causal, not casual. I do like the idea of going around and making causal inferences, but that's not what we're worried about here. So the example that I have with causal inferences is the Colorado forests have been on fire ever since that electrical storm blew through. Lightning must have struck some trees. So what's going on with the causal inferences is we're aware of a cause and effect relationship that obtains between certain phenomena. So for instance, we know that lightning, when it strikes a tree, that event often causes a tree to be on fire, and then that one tree being on fire can cause the whole forest fire. So we're using we're appealing to those causal relationships, and in this case, inferring from the effect back to what we think the cause must have been. You can also, and this is when causal inferences start also being predictions. We can also, if we have a cause, we know that a particular event tends to have a particular effect, by which I mean cause a particular effect. Then we can make a conclusion about the future. So then we have a causal inference that is also at the same time a prediction. And in this case, we have a pretty strong argument, being that there was an electrical storm that happened to occur a little bit before this forest fire, and because of these causal connections, it's very likely that it was lightning hitting a tree that caused a fire. But of course, it's not going to be a deductive argument for that reason. Why? Because even if an electrical storm blows over a forest, it could be that no lightning hit any trees, they hit other objects, or even though they hit trees, it wasn't enough to cause that tree to catch fire, or even if it caught fire, that fire didn't spread for whatever reason. And instead, what caused the Colorado forest fire in this case, there was somebody that happened to be camping, and because of the wind of the electrical storm, it blew the embers from this person's campfire into some brush, and then that caused a fire, et cetera, et cetera. So just because these premises are true here in my example, and because of these causal relationships, it'll still be an inductive argument, not a deductive argument. It's not a position to guarantee the conclusion with 100%, which is what you need for a deductive argument. So let's use the information that we've been covering to decide whether arguments are deductive or inductive. So this first case I have here, our first premise tells us that 90% of 40-year-old women in the US live to be at least 50. And then our second premise says that Helen is a 40-year-old woman who lives in the US. Therefore, Helen will live to be at least 50. So why don't you pause the video and decide whether you think it's a deductive argument or an inductive argument. Okay, if you maintained that this was an inductive argument, you're right. So premise one, since it tells us that 90% of 40-year-old women in the US live to be at least 50, and premise two tells us that Helen is a 40-year-old woman, then based on the information that we have available to us, All we know is that Helen has a 90% chance to live to be at least 50. But our conclusion makes a stronger statement. It says that Helen will live to be at least 50. So our conclusion only has a 90% chance of being true. So we're relying on probabilistic reasoning to get us to the conclusion. So it's a pretty strong argument. You know, you have a 90% chance of that conclusion coming out to be true. So it's a pretty strong argument, but it's not this all or nothing guaranteed necessary reasoning that we have in deductive argument. The next argument that we're going to look at is in this yellow circle over here. And again, we're trying to determine whether it's an inductive argument or whether it's a deductive argument. And its first premise says that it's true that 2x minus 3, 2 times x minus 3 is equal to 11. Therefore, x is equal to 7. So pause the video, take a moment, decide whether you think this is an inductive argument or a deductive argument. All right, if you said this was a deductive argument, you're correct. And hopefully one of the major factors in deciding that you used to decide that this was a deductive argument is the fact that it's an argument from mathematics. Right? This is a standard a standard math problem that you might see early on in an algebra textbook. The other thing that you may have relied on is the fact that if premise 1 is true, the conclusion definitely has to be true, right? It guarantees the conclusion to be true. Why? Because if we substitute that 7 in for x, we get 2 times 7, which is 14, 14 minus 3, which is in fact equal to 11. So let's now look at this other argument and decide whether it's a deductive argument or inductive argument. It says all wines are beverages. Premise 2, Chardonnay is a beverage. Therefore, Chardonnay is a wine. So again, pause the video, take a moment to determine whether you think this is an inductive argument or a deductive argument. Okay, if you maintain that this was a deductive argument, good, you're correct. And hopefully one of the main reasons that brought you to that is the fact that what we're dealing with here is a categorical syllogism. Wines being one category, beverages being another category, and Chardonnay being the other category. And if you maintain that this was an inductive argument, one of the reasons why you may have been led to that conclusion is that the conclusion doesn't actually follow. It's not guaranteed by premise 1 and premise 2. Now that doesn't mean this is an inductive argument. What it means is this is a bad deductive argument. It's not a good deductive argument. And if you might be confused as to why this is a bad argument. So it says, all wine are beverages. To say that Chardonnay is a beverage is the same thing to say that all Chardonnay are beverages. And the conclusion is that all instances of Chardonnay are instances of wine. And you might have thought that this was a good argument because all of these happen to be true. But notice we just based on this information, these two premises here, for all we know,
we could have a world in which we have our category of beverages, our category of wine, and our category of Chardonnay. And notice that these don't overlap at all. Now, granted, we know that that's false, but that's besides the point, because all this premise says is that everything that is a wine is an instance of wine, is an instance of a beverage. This, because it's completely within the category of beverages, makes this true, right? So even though this is true, well, this will make this true. And the same thing goes with this premise only when it comes to our category of Chardonnay. Our Chardonnay falls completely within beverages, so that makes this true. So notice that just because these two premises are true, it doesn't guarantee, forgot to put the Chardonnay there. It doesn't guarantee that all Chardonnay are instances of wine, because our Chardonnay, as far as we know, could be completely excluded from wine. So it ends up being a bad argument. So now we're going to turn our attention to this argument that I have here on the bottom in green. And so our first premise says that recent study reports that over 4 billion people drink Coca-Cola at least once a week. As a result, someone somewhere is drinking a Coke this very minute. So again, pause the video, decide whether you think this is a deductive argument or an inductive argument. Okay, if you said this was an inductive argument, good, you're correct. And the reason why is because there are 4 billion, I mean, if it's true that there's 4 billion people who drink Coca-Cola at least once a week, that's a whole lot of people. And so it makes it very likely that anytime I maintain that someone is drinking a Coke this very minute, there probably is, there's probably at least one person doing that. The problem, so you may have thought that this was a deductive argument because of how many people that we are talking about here. But, as unlikely as it might be, it could be that everybody drinks, all these 4 billion people drink Coca-Cola on Monday. So if that's true, and today's not Monday, and I say someone somewhere is drinking a Coke this very minute, our premise will be true, but our conclusion will be false. So it doesn't give us this necessary all or nothing type of reasoning. It doesn't even purport that. It just purports that it's really, really likely, given that we have over 4 billion people drinking Coca-Cola at least once a week. So here's the last argument that I want us to look at and determine whether it's inductive or deductive. Our first premise is the Chemistry 458 syllabus indicates that exam number 1 will be given on September 16th. Therefore, exam 1 will be given on September 16th. All right, so go ahead and pause the video and make a determination about whether you think that's an inductive argument or a deductive argument. If you maintain that this was an inductive argument, good. It is in fact an inductive argument. And there's at least a couple of ways that I see that might lead you to believing that this is an inductive argument. You may have reasoned that because your professor is the one who puts together the syllabus, and your professor is an expert on when exams will be given, that this is an argument from authority, which would tell you that this is an inductive argument. You may have also reasoned that it's an argument from signs, being that the syllabus is a sign about how things will take place in your course, how it's going to be structured.
and that would also lead you to this being an inductive argument. Some students I've noticed in the past will want to maintain that this is a deductive argument, and I think it's because we'll typically confuse arguments from. It's not atypical to confuse arguments from authority and arguments from science as being deductive arguments when they're inductive. But for maybe if you're a freshman, you won't have known this, but for sophomores, especially juniors and seniors, you'll be quite aware that not only is this an inductive argument, it's probably a bad inductive argument. It's, at least in my college experience, when professors maintain that an exam will be on a particular date, it almost never is. We didn't get to all the material as soon as the professor expected, so the exam gets pushed off a class or two or something of that sort.